Well, good morning, period one chemistry. Well, it's Friday. My wife just texted me that Fresno Unified canceled classes. I hope you're here taking these notes. Anyway, by this time, you should already have your calendar updated. So let me put this over to here. So, I'm going to go over the last part of the MVP triangle. Your homework the other night was to do the mole, molecules, mole. That should have been done by now. Today, we're going to get started on moles and volume. And the magic number there is 22.4. So that's easier. It's the easiest one of all of them because it's not a big number and you don't have to change it for everything. And then, so your homework that I'll stamp tomorrow is going to be the the sheet we work on today, mole and volume, as well as the one we did on Thursday, which was mole, molecule, mole. And both of those have help videos on my website. You can click on those to get help. So, with that, you should have your notes out. We're going to finish the last part of our MVP triangle, the most valuable player of chemistry. Up to now, we've got this done in our notes. So hopefully you've got this little add-on. If you don't, it should be over by the door where the Eiffel Tower is. So we've talked right now that the most valuable player, the MVP of chemistry, is the mole. The mole concept allows you to connect what you can see on the periodic table, those weights that we have. You can convert that with the scale into mass. You can take the mass, if you measure out something, you can figure out with conversions, you can figure out how many atoms or particles. Now we're going to talk about if you have a gas. So this volume is only for gases. It doesn't apply for liquids or solids. If you vaporize some matter and it turns into a gas, we can figure out how much of it is there. So we've got all of this. So to begin with, let's get cracking here. So up to now, anytime we're starting at the mole, we are going to be, we're going to be multiplying by the conversion factor. The mole going out to mass, we're multiplying by molar mass. If we're starting at the mole and we're going over here to particles, we're multiplying. Well, the same thing's going to happen if we have a gas formed. We're going to multiply, and the magic number, and you know it, you can see it on your chart right here, is 22.4 liters. So I'm going to turn this sideways. So our conversion factor going this way, you will be multiplying by 22.4 liters of gas. That's L for liters. We should have already written it up there. And since we're coming from the mole, divided by 1 mole. So this is no different than the homework we've been doing for almost a week. You're either multiplying by a number. In this case, tonight's homework, it's 22.4. Now, if we start at the number of liters up here, then you're going to be going this way. And when you're going when you're going to the mole, to the middle of the MVP triangle, it's a process of division. So, if we start up here with a certain number of liters, we have to go this direction. And the conversion factor is going to be, well, I'm just going to put it on here. Let's see, we're going to the mole. So since whenever we're going to the mole, you put 1 mole. Naturally, if it's an equation, you'd be putting what the chemical is. So I'll zoom in there for you. So 1 mole of the gas, and since we are coming from number of liters, this would be 22.4 liters of gas. So that's our conversion factor. When we're going, if we're given liters, you take the liters, you put that over 1, and then you come to, it'll change it into moles. So, once again, we're practicing getting these set up, and I know it's a pain to have to write the given over 1 with the chemical and the unit, but it's getting you set up for when we start doing a problem like this. Next thing we're going to do is learn about mole to mole ratios, how you connect one chemical to another chemical. That's coming up later in the week. So with that, you've got this. Let's open up your packet. Mrs. Hopper, if you need to pause this for a moment while they get their packets out, you can do so. All right, so If you're having trouble with this, okay, you need to figure out how to you're dividing by Avogadro's number. You're multiplying by Avogadro's number. And these over here, you are multiplying by Avogadro's number, then you're multiplying it by how many atoms in the molecule. I have a help video for that, as for this one. So let's come over here to our friend, mole volume problems. Okay, if you start off with 1 mole, now it does assume when we talk about that 1 mole of a gas is 22.4 liters. You can see next to the podium over here, I got the square over there, that's 22.4 liters. That is assuming we are at standard temperature and pressure, 0 degrees Celsius and 1 atmosphere of pressure. Okay, so that's the assumption we make. But, okay, we are starting with moles. We are starting here at the center. We're going to convert here into liters, so we're going to follow this. We're going to multiply by 22.4 liters over 1 mole. Okay, let's be thrifty. Let's just make that the given over 1. And we're going to set up, we're going to multiply that by, let's see, what did we say over here? We're multiplying by 22.4 liters of H2. Remember, don't forget the unit and the chemical in every 1 mole of H2. If you can diagonally cancel those off, you set it up right. You're done with that one. The rest of these are the same thing. It's pretty easy. These are multiplying by 22.4. Over here now, how many moles of the following are in this case, 11.3 liters? Okay, so now we're starting with liters. We're over here. In fact, if we're going to our notes, if we're going from liters to the mole, we're dividing by 22.4. So I'm just going to make this the given over 1 because that just saves time. And then we're going to multiply it by, let's see, now we got liters in the numerator. Yeah, we need to be, we're going to divide it by 22.4 liters of Cl2. That's not copper iodide. That cancels. That should tell you set it up, and 22.4 liters of any gas is 1 mole of that gas. In this case, the gas is chlorine. There you go, 11.3 divided by 22. And let's see. Tricky down here. I'd recommend you have this guy sitting next to you. Okay, let's see if you can. This is the first multi-step. How many liters will the masses of gases at STP, wait a minute, how many liters will the mass, okay, yeah. So we're starting with 100 grams. On your MVP triangle now, we're starting over here. So we're going to put the given over 1. So let's do that. 100 grams of O2 over 1. We need to change it into moles. So we're going to do this as a 2-step conversion. I'm going to go ahead and get this set up. If you prefer parentheses, then you can do that. This is a 2-step conversion. And if you're not sure how you know that, if we're going from grams to liters, take a look. We're at grams. We've got to we got to divide by the molar mass, and then we got to follow this roadmap. We got to multiply by 22.4. So let's come back over here. 100 grams of O2. Let's see, oxygen is 16 times 2. 32 grams of O2, and you can get that off of your list that we've worked on. Make sure we're centered here. Is 1 mole of O2. All we've done is, this was homework from 2 nights ago. We're just doing this part. Now we're at mole. We've canceled off grams. Now we just want to change that into liters of oxygen. Well, if we have this, we're going to say 1 mole of O2 gas is how many liters? Yeah, right there, 22.4. 22.4 liters of O2. If the mole of O2 cancels with mole of O2. So here's what you're going to do. You're going to do 100. Now, if you have a scientific calculator, you can do 100 divide 32 times 22.4 equals. If you have one of those Casio calculators, you might need to multiply these two, hit equals, and then divide by 32. Goodbye. Have a great day. Your job is to finish this the rest of the period. So long. And last night's homework. Where's the stop button? Hello? Wait. Good. Bye, everybody.